My research is in synthetic inorganic organometallic chemistry, and I'm interested in the molecular design and synthesis of new classes of light-emitting materials, and try to understand the nature of the light emission and how one can really use chemical methods to tune the emission colors as well as energies. I was inspired by the very colorful world we have in nature, and so I'm very much interested in the very colorful transition metal complexes. So what I'm doing here is I make solutions of my metal complex. Dissolved oxygen has to be removed using liquid nitrogen because oxygen usually would quench phosphorescence. This solution, which is free of oxygen, will be used for measurements of the luminescent properties. You can see the very different colors, like rainbow colors here. And actually it's the same compound dissolved in solution, but just the different solvent composition would affect the extent of their interaction between molecules and will give you very different colors. And so we try to understand how we can control these interactions in order to assemble the molecules. Some of our luminescent materials can be used as OLED materials. OLEDs is in fact organic light emitting diodes. These are materials that will show luminescence when you apply a voltage onto it. Particularly if we can find the way to make the three primary colors, the blue, green, and the red, then you can have multicolor, full color display devices, as well as you can also make the white organic light emitting diodes, which will be very important for solid state lighting. We are finding more energy efficient processes for lighting. So that means with lower power input, you get the same brightness. And so it's sort of more energy saving.